1 terabyte of data and just cut that, let's say, in half as an example, and then just reshard it or share the data across to the other nodes so that you can finish the job much faster instead of waiting for that one system to churn through all 1 terabyte of data. And as I mentioned, this is both for batch and stream processing. So that's data flow, but now what we found is that also some customers, they may have, analysts that they might not necessarily know how to code well. And so we have this data prep service, and what it is it might be a little hard to see at the back, but this is a UI-driven data preparation, a data wrangling tool that allows you to easily do things like by looking at the histogram at the top, you can see what the distribution of the data looks like. You can see if there's any anomalies and say if there's a null value, change it to 0 instead of null because your pipeline expects certain data points of a certain value. And all that is UI driven, so you don't have to code. And also what's neat about this is there's ML, machine learning, built into this. And so it will automatically suggest certain transformations for you, given what you've done in the past, or even just looking at the data. So it makes it really, really easy to do. But also, one more point I want to make here is that when you have created these quote-unquote recipes, after you've done that, you can say hit run. What it does then is it sends a data flow job, so the previous service that I just talked about, and data flow is the execution engine for data prep. So all the nice things about auto scaling and sharding, all of that is automatically done for you. Then this just becomes the UI for data flow. Okay, so any question? Okay, so I'm just going to jump into a quick demo here. Instead of showing you a slide from BigQuery, I'm just going to jump right into a demo. All right, so what is BigQuery? So BigQuery is a data warehouse on GCP. What it allows you to do is you can just dump any amount of data you want into BigQuery, and you would write basically just a simple SQL query that you are already familiar with. Right, so I'm just going to, so this is the UI, and actually this is the console for GCP. And so I'm in the BigQuery section, and what we're looking at here is Wikipedia benchmark data. So I'm sure all of you are familiar with Wikipedia. So what we've done is we've taken Wikipedia data. So this particular data set is called 100B for 100 billion records. And if I just quickly adjust the windows a little bit here. So the table has values such as year, month, day, the title, number of views for each of the articles. And I can go to review to just quickly look at the type of data that's in this particular data set. And if we go to details, you can see that we have, as a table size, we have about 6.7 or 6.8 terabytes of data with 106 billion rows, which is quite a bit. So, just going to scroll down here. And so this particular query that I'm going to write is, just going to hit run here. What that is, it's just doing a regular expression match to look for the text G, wildcard, G, O, wildcard, O, and another G. And it's going to look through 100 billion rows. And what you will notice is that on the right, it says it's going to process up to 4 terabytes of data. So remember, we have more than 6 terabytes, but here it says it's going to go through 4 terabytes. Why is there a discrepancy? Right? So actually what it's doing is that BigQuery is a columnar database. So it's, if, for example, in my query here, you can see that I'm really only selecting language, views, and also title. So it's only 3 of the, I think, 6 columns that I have in my table. So then it's going to totally ignore the other columns that it's not using. So instead of running it through all 6 terabytes or 6 or 7 terabytes, I'm going to go through 4. And after I hit go, it spreads out the data across hundreds or thousands of nodes, and it's going and return the query result to me. And what you saw just now, I think it finished at 31 seconds. Sorry, I don't know if you can see it in the back. Maybe I'll blow up the font a little bit. But it finished in 31 seconds. And it processed 4 terabytes of data. And if we go down to the result, sorry, the window's a little small. Just adjust this a little bit. And so here's the result of the query that I just ran. And so it's super easy to use, and we've already found a lot of customers doing is that they are putting, instead of having traditional data warehouses, and those are very, very costly, cost tens of millions of dollars to maintain a data warehouse. What they start gravitating towards is using a service like BigQuery. And I think our slide later on, so I'm not going to read that. But this is where you write the data into BigQuery and just write a simple SQL query that you're already familiar with. Now, for the next demo, I wanted to show this new service called BigQuery ML, or BigQuery Machine Learning. What we found is that given you already have your data in BigQuery, what some customers want to do is they want to build machine learning models right where the data is. And also, some customers, they don't really have folks that are highly technical and know how to write Java as well as building machine learning models, for example. So what we've done is we've created a new service called BigQuery ML, or BigQuery Machine Learning, so that you can create machine learning models right in the BigQuery UI. So here I have, let me just close this for a little bit. So what I have here are some data for looking at flight and delays. So let me just quickly show you what some sample data looks like. So these are some of the data points that I have, right? So arrival delay. So again, these are flight data. So if you look at, for example, the origin, so where is this person flying from and to, who is the airline, or which is the airline, the arrival delay, so how late they were, and so on and so forth. What is the distance? And so these are the different features that for this particular sample, or this particular demo, I'm going to be using these to build a machine learning model. And let me just go back here and show you what the query looks like if you want to run and create this model. A little challenge with the small screen here. So all you have to do is just write create or replace the model. So if I've already created the model before, replace it. I'm going to call it flight.rDelay. And I'm going to create a linear regression model. And I want to predict the arrival delay. So this will be my label. These are the features that I want to use. And this is the data set that I'm going to use. Right, so I'm not going to run this. It takes about a minute or so. But I've already created a model ahead of time. And what that allows me to do after a model is created is to write another query to do prediction on it. So I'm just going to hit run here first. But you see that essentially this is just another query, right? So I'm calling this particular model, which is the one that I just showed you, or I just created in the last query. I'm looking at American Airlines as the carrier. I want to fly from Dallas to LA. And I want to estimate, or I want to predict what my delay is going to be. So after running that, you'll be able to see that these are the results that I got from the prediction, right? So depending on when my departure delay is, I could see different results. And so this example here is only for, I'm only building a model for linear regression, but it also supports other types of models such as logistic regression to do binary as well as multi-class identification.
Did you try it in real life?
Did I use this in real life?
Yeah, with the airlines.
Oh, that's a good question.
Is this real data or just this?
This is real data.
Yeah, so
It's
you
public
can-
data set, but I also haven't tried because I don't rely on this. My problem is that I missed my flight once and I'm paranoid. So I would go to the airport 3.5 hours before my flight every time. So just to avoid problems like this. So that's exactly, that's not that I don't trust BigQuery ML, but I just don't. Sorry, there's a question at the back.
Is the list of model expandable? Like, can people put in their customized library?
So that, you mean like linear regression versus other types of models?
Yeah.
Or- yeah, so this is not expandable, but I believe where we're going is that we want to make it really easy for folks to build machine learning models. So I think there will be more types of models that we can build as we go. This is still fairly early. I think it must be in beta still, so it's still early, but we're going to keep iterating and make it more useful.
Or the other way around, like if the list is fixed, is there any way that we can customize a specific library inside of it?
So there is no library. So yeah, so this is all just standard. If you want to do anything that's more custom, then there are other ways to build models, but it just won't be with this particular service.
Not from this part.
Yeah, not with this particular one.
Do you have all the 649 data?
649 data? My dad asks me that all the time. He asks me about 649. He asks me about horse racing. I'm worried if I show him this, he's going to be like, yeah, so where is my model? So I might have to look into that.
Why not try?
I should, right? That would be a great demo. And I can't share that model with you afterwards. I want to be the only person winning. So one last thing I want to quickly show you on this is, let me see if I have it here, is maybe this one. So, I think it's here. So this shows, yeah, she's not here. So I talked about this is machine learning, but I didn't really show you the back end of what it's actually showing or doing. What this does in the back in BigQML, what it does is that it goes to a number of different hyperparameter tuning automatically for you so that you don't have to, say, figure out things like learning rate. It'll just automatically figure it out for you, and how many iterations you run and things like that. So I don't have that table here, but that's something that can automatically take care of for you. One thing that I didn't talk about was pricing. Like this is the BigQuery is the one where internally we call this a happy meal because every time you use BigQuery, it only costs less than a happy meal to use. The way we charge is the two aspects to the pricing mechanism. One is by storage, so how much data you're storing in here, and I think we only charge 2 cents per gig per month, which is nothing. And then also we charge for the amount of data that we query. So just there, you saw me running a query on 4 terabytes of data. That cost me about $20. And so that's, $20 coming out of my pocket is a lot, but then it's an organization running your data warehouse. I'm sure if you have folks that are in that field, then you probably know how much it costs to manage that. And so we have a customer, Lloyd's Banking Group. They went from taking 96 hours to run the report to finishing in 30 minutes with BigQuery because of how fast we were able to scale the data, scale the insights out. And when I see that 96 hours, it just boggles my mind because if I have to run reports and typically 96 hours on a daily basis, I'll never see a daily report that's relevant anymore, right? Nowadays, it's all about speed, right? If you have to wait 96 hours, then I'm going to not use it because the data is just not relevant anymore. So being able to create and get intelligence out of data fast is very, very useful. And so just now we covered BigQuery for analytics, talked about data flow. Now I'm going to quickly talk about ML engine, which is machine learning engine. So what ML engine is a platform as a service for TensorFlow. So TensorFlow is our open source framework for building machine learning models. So earlier the question around customizing and building other types of models, you would use a service like this. And you just write Java or Python code in TensorFlow to do what you want to do. And so that TensorFlow is something that we use internally to build our machine learning models. And so we open sourced it a few years ago, and it's become the de facto framework that most folks that are in the field, they do tend to gravitate towards. Nice thing about ML Engine is that it automatically scales, and so very similar to all the other types of serverless technologies that we have. You don't have to specify